If we have the information about the frequency with which an event occurs, we can find the empirical probability of an event. We can also find the conditional probability. Remember, the probability of A given B is the conditional probability that A occurs given that we know that B has occurred. This means we can look for the frequency A occurs only among the times B has occurred. For example, the table records the rounded average daily temperature in a city. So again, success in math and life is largely a matter of habits. This table should have a totals column, and so we find out the table covers a period of 30 days. We can use this to find conditional probabilities by focusing on periods of interest. For example, there were 10 plus 1 plus 0, 11 days where the temperature was at least 70. Of these days, and only these days, 10 of them had a temperature of at most 79. So given that the temperature was at least 70, in other words, were among these days, the probability the temperature was between 70 and 79 was 10/11. And that gives us a conditional probability. Or maybe we have a two-way table. A survey of dessert choices at a banquet produces the following information. What about the probability a person who had ice cream also had cake? Well, in the second case, we know the person had ice cream. So they must be among the 25 who had ice cream. And of this group, 11 had cake. And so the probability a person who had ice cream also had cake is 11/25. Or let's consider another situation. Suppose that on a final exam, 70% of the students who understand the material pass, while 90% of the students who don't understand the material fail. Suppose that 80% of the students understand the material. So note we have two events of interest. A student understands the material, we'll call that U, and a student passes the exam, we'll call that P. We'll set up a two-way table using these events and their complements as the row and column labels. And since we're given percentages, we'll set up a frequency table with 100 times 110,000 students. Even if we don't actually have that many students, we'll use it as our baseline. So we're told that 70% of the students who understand the material pass. This is a conditional probability. We're focusing on the students who understand the material, and that gives us the probability of passing given that we understand the material, 0.7. But since we don't know how many students understand the material, we can't use this probability yet. Finally, we're given the unconditional probability that 80% of the students understand the material. This means 80% of our 10,000, or 8,000, understand the material, and the remaining 2,000 do not. Now we know how many understand the material, so we can use our conditional probability. So 70% of those 8,000, or 5,600, pass, and the remaining 2,400 do not. Likewise, since we know how many students don't understand the material, we can now use the probability they don't pass, given that they don't understand the material, 0.9. So 90% of 2,000, or 1,800, do not pass, and the remaining 200 do. And again, we should always find the totals, so let's extend our rows across to find the total number who passed and the total number who didn't. So let's find the probability a student who passed understood the material. So this is a conditional probability. We know the student passed, so this is the probability of U given P, and of the 5,800 students who passed, 5,600 of them understood the material, and so that frequency is 5,600 out of 5,800, or about 97%. The probability a student who failed understood the material is also a conditional probability. We know the student didn't pass. This is a probability they understood the material given that they didn't pass. And there's 4,200 students who didn't pass, and of these students, 2,400 understood the material. So the probability that someone understood the material given that they didn't pass is 2,400 out of 4,200, or about 57%.